Hey, good morning, all you MRWC fans. This is Mr. Ainsworth, and we are going to get into a little prep discussion for Activity 5C2. So let's go over the basic skills one by one. All right, and you're going to be interacting with me in this video here. There'll be some questions throughout the video that you have to answer. And so take detailed notes, go at your own pace. You know, you can always pause, play, rewind, make sure you do that. And go at your own pace. All right, so here we go. Skill number one. So skill number one. Okay, it's called squaring a binomial. Squaring a binomial. So how do you do that? Let's go over the basics. Okay, now let's put the let's keep the skill in red. So when you square a binomial, I'm talking about a plus b, and you can square any binomial. I don't care what a and b are. They could be real or imaginary. They could be variable. It doesn't really matter. Okay, instead of using FOIL, all right, it's always equal to, all right, a squared plus 2ab plus b squared. That's called the structure of it. If you go back and look at your notes from section, I don't know, 3, we've done this a long time ago. Whenever you square a binomial, you end up with the structure. So that means you square the first, okay? So square, and then 2ab means you multiply a and b. AB means a times b, and then you double it. 2ab means you double the product. So you multiply, double, so you multiply, and double, multiply, double. Okay, and then you square the last. Okay, so square, multiply, double, square. So square the first, multiply, double, that's your middle term, and then you square the last. So square, multiply, double, square. So let me illustrate how it's done by going through a couple examples here. So let me take a complex number, because we're in the complex field right now, and let's square it. I'm going to square the 2 to get 4. I multiply the 2, okay, I get negative 2i. So I think negative 2i, but then I double it, and I get a negative 4i. So I'm going to write down minus 4i. So I multiply double. That's that 2ab in the middle. It's called the middle term. And then you square the last. Okay, so negative I times negative I is positive I squared. So plus I squared. Now you got to keep in mind that in the imaginary field of numbers, okay, well, I squared is always equal to negative 1. We know that. Okay, so remember that. So really this is equal to 4 minus 4i minus 1. 4 minus 1 is typically 3. And then so you have 3 minus 4i. Why? Because the 4 minus the 1 gives you 3. You got to subtract the real parts. And remember your I squared right here, that's just negative 1. That's why I brought down the minus 1. So I take the I squared, I think negative 1. Negative 1 plus 4 is 3, and then I have that minus 4i. And that is in complex Cartesian form. So a plus bi, it's called complex or Cartesian form. Okay, now that's just one example, so let's do another one here before I hit you with a little quiz question here. Let's try another one, okay? I'm going to pose it, and then I want you to pause and play and try it before we go to the quiz question. So let's suppose you have 3 minus 4i squared, okay? I want you to square the first, multiply, double, square the last. Do not use FOIL. Okay, I mean you can, but that's I want you to guys got to learn how to train your mind and use a structure so that you can do things quicker, because when I start combining skills, if you know these basics, well then you're going to be okay. All right, you're going to follow things better. You're going to be able to do things better, and you're going to be more successful. Okay, pause the video, go for it. Okay, now let's check your work. You square the 3 to get 9. You multiply the 2. So 3 times negative 4i is negative 12i. But if you take negative 12i and double it, okay, you get negative 24i. So I'm going to write down minus 24i. And then you square the negative 4i to get 16i squared. Negative 4 squared is 16, I squared is I squared. So that gives you 9 minus 24i minus 16, because that negative 1 the I squared is negative 1, and 16 times negative 1 is negative 16. 9 minus 16 is negative 7, so you get negative 7 minus 24i. Okay, so now there's going to be a quiz question, so here we go. Okay, skill number 2. Skill number 2 is the very famous Algebra 1 difference of squares. Comes up a lot. And we started using this and practicing this a long time ago as well in previous units. But I want to go over it again because it's an important one. So a plus b, all right, times a minus b. This is your famous difference of squares. And if you multiply out, you're going to get a squared minus b squared. So all you have to do is square both of them and subtract. So that's your structure. Okay, so basically in your mind you have to square both terms. Okay, and subtract the results. Square both and subtract. That's it. So let's go through some examples here. So let's take the structure 2 plus 3i minus 2 minus 3i. So notice this is in the same structure. Okay, this is a plus bi times its conjugate, a minus bi. So whenever this applies whenever you multiply conjugates. And that's always equal to the difference of squares, a squared minus b squared. So when I do this, I take 2 squared minus 3i squared. Notice how I put 3i in parentheses, because I got to square both the 3 and the I. So I get 4 minus 9i squared, but that gives me 4 plus 9, because negative 9 times 1 is 9, all right, which gives you 13, which is a real number. And whenever you multiply conjugates, all right, you always get a real number. Always, 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 always. We talked about that. You always get, a squared plus b squared. Okay, but don't get confused between that and what we're doing, okay? All you do is square both and subtract, and remember that I squared, okay, is always equal to negative 1, all right, in the complex field. Let me show you again, something very simple. So let's suppose we have 5 plus 2i times 5 minus 2i. All I'm going to do is square both and subtract. So I square the 5 and I square the 2i. Look at that. I square both and subtract. So you'll see the squares and you'll see a minus sign. Just say to yourself, square both and subtract. And then you write it down that way. So 5 squared is 5 times 5, or 25. 2 squared is 4. I squared is I squared. But you know that I squared is negative 1, so you get 25 plus 4, because a negative 4 times negative 1 is 4, so an end result of 29, which is a real number. So whenever you multiply conjugates, you always get a real number. Okay? Key point number 2, or another key point, is that when multiplying conjugates, you always get a real number. When multiplying conjugates, I'm talking about complex conjugates, you always get a real number. Okay. Now, if these were not complex numbers, well then, you're going to get some other kind of expression. But in general, because we're in the complex unit, section 5 in MRWC is all about complex values. Whenever you multiply complex conjugates, you always get a real number. We actually proved that in class. All right, let's try another skill. Skill 3. So skill 3 is combining skills. Okay, so what am I talking about here? This is, here's the challenge one. Let me pose the problem here. So let's suppose we have 3i plus root 2, and then minus 7, so a trinomial. And then let's suppose we multiply that by 3i plus root 2 plus 7. Okay, now in this problem here, we're going to be combining skills, because you notice that if you consider 3i plus root 2 as your first term, this is like your a right here. This is like your b, this is a, and this is like your b. So this right here, the first two terms are considered the first term. And then you'll notice that you have a minus b, all right, times a plus b. So notice the plus sign here. So there's your structure, and it's going to be equal to a squared minus b squared. Again, it's the difference of squares again. But within this structure, you're going to see something else come out. Okay, so let's go ahead and go for it. So you're going to square both and subtract, just like the previous skill, right? That's what I said. Difference of squares is always a squared minus b squared, so you square both and subtract. But this time I've got to square the 3i plus root 2. So since it's a binomial, give it a hug, square it, and then take the 7 and square that. So you square both and subtract. Square both and subtract. That's your structure. All right. So now, this part, when you square a binomial, that, my friends, was skill number 1. Okay, so that's what I mean by combining skills. Now we're going to have to square, multiply, double square. All right, so square, multiply, double square. So let me put that in red. So square, multiply, double, square on this one. So here we go. Just the binomial squared. So you square the 3i to get 9i squared. You multiply 3i times root 2, which is 3i root 2, and then you double it, you get 6i root 2. Why? Because if you double 3, you get 6. Okay, it's that simple. And then you got to square the last, okay, which is the root 2 squared, which is just 2. And then if you square the 7, you get, obviously, you get 49. That's simple. Okay, so now we have to simplify a little bit, so let's do that. So 9 times negative 1 is negative 9, plus the 6i root 2. 2 minus 49 is negative 47. Okay, and then once you have that, okay, negative 47 and negative 9 is a negative 56. Again, you add like real parts right there. And then what do? So you add the 6i root 2. Okay, and that is in complex Cartesian form. All right, so now I want you guys to try it. All right, so let me see. Let me make up one here. So you can, let's see here, something similar to that. So let's try 4i plus root 3 minus 5 times 4i plus root 3 plus 5. Okay, so this is the second one. All right. Pause the video now, give this one a shot, and when you're ready, press play and check your work. Okay, so let's check your work here. So just like the previous problem, we're going to consider this as A, and the second term is 5B. So A and B. So this is A, and that's B, and this is A, and this is B. And again, A minus B times A plus B is always a squared minus b squared. It's always a difference of squares. So here we go. So we're going to take 4i plus root 3, square it, and you got to take your 5 and square it, and you got to square both and subtract. Again, that's why it's the key skill right here. Square both and subtract here, and also here. So now you expand your binomial. And you do that by square, multiply, double square. That's what I was saying. You got to be able to combine skills. So you square the 4i to get 16i squared. You multiply 4i times root 3 to get 4i root 3. But you double the 4i root 3 to get 8i root 3. Remember, doubling just means times 2. And then you square the root 3 to get 3. And then you bring down the minus 25, because 5 squared is 25. So you get negative 16 plus 8i root 3, and this part right here is a negative 22. So negative 16, negative 22 is a negative 38, plus 8I root 3. Okay, again, always combine the real parts. Negative 16, negative 22 is negative 38. All right, let me see. We have 2 more skills to go. So, skill 4. I'm going over all the different skills for you to be successful in your next activity, which is not an easy one. Okay, skill 4 is conjugates. All right, and the previous skill of difference of squares. Okay, so I'm going to combine those two. Okay, so you're going to end up having something like this. Okay, so let me pose the problem. So let's suppose we have 2 root 5 plus 2i divided by 2 root 5 plus 5i. So notice the numerator and denominators are different. So we got, they're complex, they involve roots, and so you're gonna see a lot here. Okay, so now when we talked about this in the previous lesson 5C1, we used the conjugate of the denominator in the form of 1. And the conjugate of 2 root 5 plus I, okay, is 2 root 5 minus 5i in the form of 1. So the numerator and denominator are the same. Okay, now these are all binomials, and we are going to be using FOIL quite a bit here. So let's work out the numerator first. Okay, now there's a video, so if you need to pause and play and go at your own pace, do so, okay? It just calls for a lot of good arithmetic. So on this one here, I get 2 root 5 times 2 root 5. 2 times 2 is 4. Root 5 times root 5 is 5. And 4 times 5 is 20. Okay? Now, if you can't do all that in your head, you do some side work. Okay? So 2 rad 5 times 2 rad 5. Okay, you multiply the whole numbers first. So 2 times 2 gives you 4. And then root 5 times root 5 is just 5. Root 5 times root 5 is 5. Well, root 5 times root 5 is root 25, which is 5. So you get 4 times 5, which is 20. Okay, so if you want to do some side work, you can, if you can't do it on your head. And then you got to multiply over here. So 2 root 5 times a negative 5i. So that's 2 times negative 5 is negative 10i root 5. So negative 10i root 5. You multiply the coefficients. 2 times negative 5i is negative 10i times the root. Okay, now you distribute the second term. So here we go. So 2i times 2 root 5 is 4i root 5. And then 2i times a negative 5i is just negative 10i squared. Now down below is easier. Okay, now down below, this is a plus b times a minus b. Okay, which is always equal to a squared minus b squared. So you square both and subtract. As I said in the previous skill. So I'm using skills over and over again. Whenever you multiply conjugates, you always get some real number. So this denominator here is going to end up being real. So I got to take the 2 rad 5 and square it. Write down a minus sign because it's a squared minus b squared. And then you got to take your 5i and square it. Okay, now let's simplify up top. I see 20 up top. I see the 20 and then a plus 10 because negative 10 times negative 1 is 10. 10 plus 20 is 30, so I'm going to write down 30 up here. Now, negative 10i root 5 and 4i root 5. Negative 10 plus 4 is negative 6, so I get a negative 6i root 5. All you have to do is combine the coefficients. That's all you do. Negative 10 plus 4 is negative 6, so negative 10i root 5 plus positive 4i root 5 is negative 6i root 5. Now, when you square the 2 root 5, okay, when you square the 2 root 5, you square both. So 2 squared is 4, root 5 squared is 5, and so you're going to get 20 here. Minus 5 squared is 25, and then you got to square the I as well. But as you guys know, the I squared is -1. So this is 20 plus 25 actually. So 30 minus 6i root 5, all divided by 20 plus 25. Okay, negative 25 times -1 is positive 25. 25 plus 20 is 45. And then the end result, you divide both by 45. So 30 divided by 45 minus 6i root 5 divided by 45. Okay, and then you just simplify from there. So let me see. The 30 and 45 are divisible by 15. So you're going to get 2/3 here. Okay, and then 6 and 45 are both divisible by 3. Divide them both by 3. You get 2i root 5 over 15. So minus 2i root 5 divided by 15. And you can't simplify any further because you can't divide the root 5 by 15. They're unlike terms, so don't even try that. Okay, yes, that is a challenging one. So take a look at that. You practice that 10 times in a row on your own. Get some scratch paper out and practice this 10 times in a row and get good at it. And your activity will be easier, okay? Because you're gonna be able to combine skills using conjugates and the difference of squares. All right, last skill. All right, skill 5. Okay, is dealing with powers of I, the complex unit. Okay, so what do I mean? So let me pose an example here. So dealing with I to the power of, let's say 6 minus 5i times 6. Actually, before I do this, let's do this. Let me warm up here. So I to the, I don't know, 13th power. What is that? Okay, so let's go start basic before I complicate things. So I to the 13th is the same thing as I to the 12th times I. Remember, I'm just rewriting it here because I'm using the exponent laws that you learned in Algebra 1. When you multiply the like variables, you simply add your exponents. So I just rewrote it like that. And again, the key idea is that we know that I squared is -1. So the question is like, how many I squareds do we have in I to the 13th? Or in other words, how many I squareds do we have in I to the 12th? Well, I do know that if I take I to the squared and I take it to the 6th power, I get I to the 12th. And then, of course, you got to multiply that by I. Why? Because we were starting with I to the 13th, not I to the 12th. And so this is really just -1 right here inside the parentheses here. That's just -1. Remember what we know, okay? So really I have -1 to the 6th power times I. And if you multiply 6 negative 1s together, you get a +1. And 1 times I is I. Now it's not always equal to I. If I had something like I to the 17th power, let's say. No, let's go to 19th power. 19, yeah. So the 19th power. This is I to the 18th power times I. Now, the question is, how many I squareds do I have here in I to the 18th? So I think I squared to what power gives me I to the 18th? And I know that 2 times 9 is 18, so it's going to be to the 9th power. So that means I've got 9 negative 1s being multiplied together. And if that happens, I know it's -1. -1 times -1, 9 times. There's an odd number here versus an even on the previous one. This is odd. So you're going to end up with a negative I here in this case. So as long as you know how to deal with I that way, then something like this is doable. So if I have something like I to the, let's say 6 minus 5i times 6 plus 5i, you know, what in the world is that, right? So what you want to do here is you want to do a little side work. Unless you can do it in your head, of course, which I can, but let's just work on this. So 6 minus 5i times 6 plus 5i. This is the difference of squares again. And all you do is square both and subtract. So you got to take 6 squared minus 5i squared, using the difference of squares. So this is 36 minus 25i squared. And what do you get? Well, negative 25 times negative 1 is 25, so this is 36 plus 25, or 51. Excuse me, 61. Okay? So now what we have, this is equal to I to the 61st power. The question is like, how many I squareds are in there? So what I do is I say, okay, I know that this is equal to I to the 60th power times I, because I'm dealing with 61 i's here being multiplied together. So the question is like, how many I squareds there are in I to the 60th? So I squared to what power gives you I to the 60th? And the answer there is 30, because 2 times 30 is 60. Now 30 is even. So like on the first example here, this was even. And so we ended up with positive 1 here. When on the next example, this was odd. And I ended up with a negative 1. So because this is even, and I know I'm multiplying 30 negative 1's together, again, this is negative 1 to the 30th power times I, not I squared, so just I, sorry. I know I'm dealing with an even number of negatives when I'm multiplying. So that's going to be equal to positive 1 times I, or just I. And that is kind of what you have to get used to. So when you see your activity, man, you're going to have to combine some serious skills. All right, skills using the complex unit, I, where I squared is equal to negative 1, and dealing with different powers of I. And then also using difference of squares. Again, this right here, this was a difference of squared. This is a minus b times a plus b, which is a squared minus b squared. This is a difference of squares, and which I've used in almost every single example here. So this was huge skill. So to be successful on these activities, you got to build up skills, and which requires practice, obviously. So make sure you do that. All right. Now it's time for you to practice. Give it your best shot. Remember, this is a video here. So if you need to go back and listen to anything again, you may. It's totally up to you. I'm Mr. Aynesworth, and I will see you in the next activity in 5C2.